viewers. This is After Johnson, your chemistry tutor and your biology tutor. We have started talking about, in the last video we did mass relationship in stoichiometry. We want to proceed and look at one question that is very funny that students might find difficult in mass relationship. Let's look at this question. Now, this question is 9.58 gram mixture of limestone, and limestone is what? Calcium triiodocarbonate 4, and common salts. Common salt is sodium chloride, was made to react with excess dilute HCl. Excess dilute HCl to liberate 2.8 gram carbon 4 oxide. Now from here they now say find number 1. Find the mass. Okay, first write a balanced equation for the reaction. That's the first thing to do. Now, number 2 question they will ask you, they can say, okay, number two, find the mass of the limestone reacted. Number 3, they can ask you, find the mass, okay? Find the mass of the common salt in the mixture. And then lastly, they can ask you, find the percentage by mass of the common salts. Yes, that is a question for you. When you see this kind of question, what do you do? So there are some information that they still need to give you here. They need to give you some information. And what are those information? What you can use to find molar mass can be asked. Okay? Then the question is not finished. Then the rest of the question will not be that. The rest of the question will be that you open a block bracket, they write CA equals to 40, they write C equals to 12, they write O equals to 16, they have NA equals to 23, and CL equals to 35.5. So I can use it to find molar mass. To answer the first question, number 1, we'll have to write the equation. The equation of the reaction. Yes. In this place, the question says 9.58 gram mixture of limestone, which is calcium triiodocarbonate 4, and common salt. This is a mixture. But from your knowledge of acid, bases, and salts, the mixture is meant to react with excess HCl. One of the chemical properties of acid is reaction with trioxocarbonate form to liberate carbon dioxide and form salt and water. Now, that means out of this mixture, this acid will only react with calcium trioxocarbonate form. Sodium chloride will remain unreacted with. So sodium chloride is only acting as an impurity. It's acting as an impurity. Now, then we ignore this mass. Let's write the equation. So it means it is calcium trioxocarbonate form that is reacting with HCl to liberate carbon dioxide. Let's look at it. We have CaCO3, that is solid, capital 3 is solid, reacting with HCl. HCl is aqueous. Then we have CO2 will come out of this CO3, 2 minus. Then what else will be formed? Water will be formed, H2O. Don't forget, there are 3 atoms of oxygen air. Only 2 of them is forming carbon dioxide, O2. The remaining one combines with this hydrogen to form H2O, which is liquid. Then you now have plus what? Plus a salt, that's calcium chloride. How do I write the formula of calcium chloride? That's CaCl2, which is aqueous. So now, that is that. Is the equation balanced? Let's check. Now, we have 1 atom of calcium here. Calcium is balanced, 1 atom. 1 carbon, 1 atom of carbon. Now, oxygen is 3 here. At the other side, we have 1 plus 2, that's 3. But hydrogen is what here? 2. But hydrogen is 1 here. Because of these 2, we put 2 here. We put 2 there. So, now, so we have 2 HCl. Now, the 2 we put here has affected chlorine. Chlorine atom size is now 2. And also, these 2 hydrogen, 2 chlorine, then already we have 2 chlorine here. So that is that. Now, we are through with this. So, what else do you need to do? Determine, you are given, you have this equation now. This equation contains how many things? 1, 2, 3, 4, 5. So you must relate together 2 important ones. What are the 2 important ones? The mass that is given and the mass that is required to be found. 2 masses are given. 9.58 gram was given. Then 2.8 gram was also given. But this one will be ignored. Why? Because it is the mass of both pure limestone that is reactive and sodium chloride that is not reactive. It contains impurity. So that is why they ask us to find the mass here, the mass of the limestone that reacted. So out of that mixture, we ignore this one. We assume that we know the mass of CO2. Then we derive, now we know mass and we are asked to find mass. So that is mass relationship. So to do that, what do? You have mass of CO2 over molar mass of CO2 is equal to mass of, what are we looking for? Mass of limestone, CaCO3, over molar mass of CaCO3. Now, how do we get mass of CO2 that be given to us to liberate 2.8 gram CO2? Don't forget, gram is the SI unit of mass in chemistry. Now, in place of CO2, now we put what? 2.8 over, then trying to find the molar mass of carbon dioxide. Carbon has been given to us to be what? 12. we represent this C with 12. Then we put plus. We are going to oxygen. Oxygen is already what? 16. We write 16, but in the formula we have 2 oxygen atoms. Then we multiply by 2. Then equals to, now mass of, this is what we are looking for now. Mass of CaCO3. What is the molar mass of CaCO3? Calcium is 40. We put it there. Plus carbon is 12. Plus oxygen is what? 16. But how many 16 do we have there? 3. So we have 2.8 over 16 times 2 is what? 32 plus 12 is equals to mass of CaCO3 over, now we have 40. 40 plus 12 will give us what? 52. Plus what is 16 times 3? That's 48. Now, if that is it, we have 2.8 over, let's add up what we have here. We have 12 plus 32. Answer is 44. Then equals to mass of CaCO3 over, let's add up 52 plus 48. Answer is 100. Now, the next thing is to cross multiply. Let the numerator here multiply the denominator. Numerator here is what? So we now have what? 44 mass of CaCO3. Then this equality sign, we write it back. Then this 2.8 will come and multiply 100. 2.8 will multiply 100. So we have 44 mass of CaCO3 to give us, we have 2.8 times 100. Answer is 280. 280. So we divide those by 44. We have mass of CaCO3 is equal to 280 divided by 44. So then mass of CaCO3 now will now give us divided by 44. Answer is 6.4 gram. So that is that. Answer is supposed to be 6.36. It's supposed to be 6.36. So you can leave it gram. Let's leave it like that. So that is out of the 9.58 of that mixture, calcium carbonate is only 6.36. The remaining fraction that is needed to be added to this one to make it 9.58 is the mass of the common salt. So that is it. Now, number 2 question now. There, we are looking for the mass of the what? Of the mass. We have gotten the mass of the limestone. Find the mass of the common salt. So the mass of the common salt is equal to mass of the mixture. Mass of the mixture minus mass of CaCO3. So this one gives us, what is the mass of the mixture? 9.58. Then what is the mass of CaCO3 we got here? 6.36. So what is our answer going to be? Let's go on and look at that. We have 9.58 minus 3.36. Our answer is 3.22 gram. So if you add this 3.22 gram to this 6.36 gram, you will get this 9.58 gram, which is the mass of the mixture of calcium carbonate and sodium chloride. So like I told you, the sodium chloride is acting as an impurity inside this question. Then to answer the last question, number 4, I take this part away. Now, number 4 is saying that we should find the percentage, okay, salt in the mixture. Now, let's look at number 4. Percentage of the common salt. Percentage of the common salt in the mixture. Now, don't forget, so to get that, we have percentage of the common salt, which serves as impurity, will be equal to mass of common salt over mass of the mixture, then times 100 over 1. So that's the formula for that. If you are looking for a percentage of something, you are going to create a fraction in which the numerator will contain the mass, the quantity of the substance whose percentage you are looking for. And the denominator will now be the what? Will be the sample space, the universal set containing the numerator and other things. For example, then you say times 100. You want to look for in a class of 10 students where 3 are girls and 7 are boys. They say find the percentage of boys. That's number of boys over number of both boys and girls times 100. The same thing is here. You have sodium chloride and calcium carbonate mixed together. And inside you are looking for the percentage of common salt. The answer will now be what? Mass of the common salt over mass of the mixture of common salt and limestone, then times 100. So what do you have here? The mass of the common salt has been got in here to be what? 3.22. Then over, what is the mass of the mixture? 9.58. 9.58. Then times 100 over 1. So what do we have? We have 3.22 times 100 times this 100. Answer is 322 over 9.58, and the answer will now be divided by 9.58. Then our answer is 33.61 gram. Percent. So that is that. About that, I hope you have the understanding of what we have done here. So can we look at one more example before we call it a day? Now, take note of this. Okay, let me take it away. Yes. Let's look at example 2. You can say 9.86 gram of impure of impure potassium. Okay, let me use another thing. Of impure hydrogen peroxide decomposed in the presence of catalyst, in the presence of manganese 4 oxide catalyst to liberate 3.2 gram of oxygen according to the following equation. The equation is hydrogen peroxide H2O2 now is thermally decomposed in the presence of manganese 4 oxide to form water H2O and liberate oxygen gas. Now, then is the equation balanced? No. So I need to put 2 here and put 2 here. So 2 times 2 is 4. 2, so equation now is balanced. So now, okay. So what else are we doing here? Okay. Now that we have this, they will now say H equals to 1, O equals to 16. So then you have this. Yes. They will now say find the what? 1. The mass of pure hydrogen peroxide. 2. Find the mass of the impurity of the mixture. Then 3. They will say find the mass, okay, the percentage of impurity of the mixture, and lastly, number 4, the percentage of purity of the mixture. Okay? Now, with that, what do? What are we going to do? Study that question, you may write it down. You may write it down. Okay. Yes. I come back again. Yes, next thing to do, solution. Yes. We want to solve the first question, mass of the pure hydrogen peroxide. Mass of the pure hydrogen peroxide. To do that, it's not as if certain mass was not given for hydrogen peroxide, but the mass is the mass of impure. That is, it is meant for both hydrogen peroxide and other impurity added to it. So we ignore it. We look at it as if the mass of hydrogen peroxide is not given. But we are given the mass of oxygen liberated. According to the question of oxygen, the mass of oxygen liberated will be given to you. So when you know that, now it is mass to mass relationship, because you are given mass and you are asked to find what? Mass. So we develop our formula here. This one that is given, that's mass of oxygen. We have mass of oxygen over molar mass of oxygen is equal to mass of what am I looking for? Mass of hydrogen peroxide over molar mass of hydrogen peroxide. Now, what is the mass of oxygen given? That's 3.2 gram. What is the molar mass of oxygen? 16 times 2. Mind you, this oxygen is balanced by any number. You also use the number to multiply what you have there. So you have equal, so what is the mass of hydrogen peroxide? That's what you are looking for. Mass of hydrogen peroxide. What is the molar mass? Hydrogen is 1. According to what you have here. And you have times 2 of it. Oxygen is what? 16. And you have what? Times 2 also. So we have 3.2 over 32. 16 times 2 is 32. Is equal to mass of hydrogen peroxide over 1 times 3 is 2 plus 32 times 2 is 16 times 3 is 32. So we have 3.2 over 32 equals to mass of H2O2 over 2 plus 32, that's 34. Then what do? We cross multiply. To cross multiply, this 32 will multiply this. We have 32 mass of hydrogen peroxide is equal to what? Is equal to 3.2 times what? Times 34. So we have 32 mass of hydrogen peroxide is equal to, yes, let's check with calculator. We have 3.2 times 34. So our answer is 108.8. Now, we divide those by 32. The mass of hydrogen peroxide will now be 108.8 over 32. So, mass of hydrogen peroxide will now be what? Divided by 32. Our answer is what? 3.4 gram. So out of this whole 9.8 C's, hydrogen peroxide is only 3.4 gram inside. Then what is number 2?